Greetings Internet, Sean Shooping here. Welcome to part 3 in my series of over-engineering your home lab. Today's experiment is just going to be a straight up tech demo. I'm going to be building a high availability Juju controller. I'm going to use that to build a Postgres replica for me to migrate my Metal as a Service region controllers database into. I'm then going to add a secondary server for my Metal as a Service region controller so that we can make it highly available. And then we're going to put it behind the custom load balancer, which I built in part 2. Lots to get to. Let's get into it. To bootstrap the Juju controller, I'm going to stage 3 virtual machines in MAAS before I bootstrap with the Juju CLI. So while this is not really necessary, I'm doing it this way to ensure that every virtual machine in the Juju cluster does actually end up on a different physical host. Once the machines reach the ready state, I'll go to the machine configuration and add a Juju tag. I'll use this as part of the bootstrap procedure. To bootstrap, we'll switch to the Juju CLI, and the first thing that we need to do is tell Juju about the cloud I'll be bootstrapping into. So I'll simply run a Juju add-cloud, set the cloud type to MAAS, give it a friendly name, and then enter the API endpoint. The URL I'm using is actually the load balancer address I built in part 2, which sits in front of the MAAS API. Next, I'll run a Juju add-credential cloud name so that Juju can authenticate to MAAS. I'll use the default region and provide the OAuth token found in the MAAS GUI under API keys on the user preference. Now we can go ahead and bootstrap the controller. So I'll simply run a Juju bootstrap, pass a constraint of memory equals 2 gig and tags equals Juju, which we created earlier, so that the bootstrap can select one of the machines I staged. I'll follow this with the name of the cloud and a friendly name for the controller. If we switch back to the MAAS GUI, we can see that MAAS starts installing an OS on a machine which matches the request from the bootstrap. So after the bootstrap is complete, converting to a highly available controller is as simply as running Juju enable-HA. That's going to submit a new request to MAAS for 2 additional machines matching the constraint declared at the time of bootstrap. And here we can see that MAAS starts installing an OS on the remaining staged machines. To check that everything's happy, we should see 3 machines on the controller model with a state of started. So now that the Juju cluster is up and running, we can go ahead and provision the Postgres cluster for our external MAAS database. I'll go ahead and create a new Juju model with a Juju add-model, model name. And my intention is to run multiple databases for multiple apps. And one of the apps I'm going to be running will require Postgres 12. So to deploy that, I'm going to run a Juju deploy PostgreSQL --series focal and then pass a config setting of version equals 12 and deploy it directly to a machine I already staged named Postgres-0. After the DB is up, I'll need to make sure that Postgres will accept remote connections from outside of itself. So I'll run a Juju config PostgreSQL extra_pg_auth equals host all databases, all users from anywhere using an MD5 encrypted password. Once the database server is up, we can actually get to moving the MAAS database to it. To dump the local database, I'll log into MAAS and use this set of commands I plagiarized from the MAAS discourse. The first part sets a variable called pgpass from the MAAS regiond.conf file, and it gets used in the second part, pgdump user MAAS. The host in this case is a local file socket. The database name is MAASDB. The output format is T for tar. And lastly, the output file we'll call maasdb-dump.tar. That'll take a couple of minutes to run and simply drops the dump to the current working directory. After that, I'll simply SCP the dump file to the external Postgres host. And then on the Postgres host side, I can run a psql-c create user MAAS with encrypted password as the Postgres user on the machine. Next, I'll create a blank DB called MAASDB and set the owner to MAAS. I can then restore the database dump into our empty database from the dump file we transferred earlier with pg_restore MAASDB and pump in the maasdb-dump.tar. This could take some time, so make sure to run it on a screen session. Don't be like me and have to do it twice because your SSH session got disconnected halfway through. After the DB is restored, we can reconfigure MAAS and point it to the external Postgres database server. So we'll log back into MAAS and run a MAAS init region plus rack and the database URI. We can say yes to initialize again and accept the default URL. And after the database migration completes, we don't need to use MAAS create admin because we've already been using MAAS and the user already exists. So to add a replica of the Postgres database, we can simply tell Juju to add a unit to PostgreSQL and deploy it to a second stage machine I have called Postgres-1. After that completes, we see machine Postgres-1 running as a live secondary. Now we can add the second MAAS region controller, and for this I'm going to add it as a virtual machine on one of the KVM pods I deployed using MAAS in an earlier step. Interesting thing to note here is that I'm going to add multiple network interfaces to the VM and map each interface to subnets I want managed by MAAS. After the machine reaches the ready state, I'm going to configure each interface to have a static IP address so that the second region controller's IP address doesn't change over time, and then finally deploy an operating system to the VM. So after we install MAAS from Snap and initialize the second controller, it appears under the controllers section. And when we click on it, we get a notice on the GUI saying that we can now enable high availability DHCP on our fabric. So we'll need to go to each VLAN and reconfigure DHCP and select MAAS02 as the secondary controller. If any of the controllers become unavailable, the surviving controller takes over issuing IP addresses for all of the network segments. Now that we have two MAAS controllers, this means we can finally add the second to our backend configuration on our HA proxy load balancer. So I can go back into the code and uncomment the second server and then rerun the Ansible playbook I used to build the load balancer. After that, we can check the HA proxy stats URL, and here we can see that we now have two MAAS backends and each of them are reporting 200 OK. So that technically brings us to the point in the build where we have a completely fault-tolerant core infrastructure. Should anything blow up right now, I should be able to keep moving forward. But how fault-tolerant is fault-tolerant? And what's it actually like to deal with a failure condition? So in part 4, I'm going to be breaking things intentionally and see how far I can get before the lab becomes completely unusable, and then see what it takes to actually get it functional again. But as for this video, that's pretty much all I have for you. If you've made it this far, thanks for watching, but I'll see you in the next video. Peace.